Hello everyone, welcome to the class of human-computer interaction. So let's go to the second part of lecture interface. So far we have discussed what is interface, what is interaction, what are the different types and so on. So let's go for the rest of the other concepts related to it. Conceptualizing design. So it's a proof of concept. So conceptualize what a proposed product will do. So why we need to conceptualize design? To scrutinize vague ideas and assumption about the benefit of the proposed product in terms of feasibility. It also helps us in realizing how realistic it is to develop it, how desirable and useful it will be. So conceptualizing everything will help us giving a thought about how and which direction we will be proceeding to help user in achieving the goals. With this example, you can see that by conceptualizing design itself made Steve Jobs one of the most popular person in the tech industry at that time. As you can see that Steve Jobs has visited Xerox Palo Alto Lab and he has seen Xerox Star UI. Xerox was leading company which is making machines, printers, where you can do copying, printing and so on. They soon realized that the computers are going to replace them. Then who is going to probably do all those files? Inspired by this, they have built a system called Xerox Star UI. As you can see that Xerox Star UI looks like one of the modern computer at that time. You can say that having this is something called mouse. They have a kind of screen where they can see what is happening, that is graphical user interface. Their systems are connected with the network and so on, so that they can exchange the files with different files. So when Steve Jobs visited Palo Alto office, Xerox representative have told them three novel things they have probably introduced in Xerox Star UI. GUI, OOP, networking. Steve Jobs, in one of his interviews, has said that he got the inspirations to build his Apple laptop from Xerox Star UI. He said when he has visited Xerox Palo Alto Lab, when the people started explaining the things, after listening the first one GUI, he just ignored or probably did not listen to the other things because other two was not a bit novel to him. What has inspired him or probably what he was got amazed with? The GUI. And immediately he realized that this is going to be the future of computers, and that's where basically he has built Apple desktops, computers, and since then he never looked back. So often, and that was his assumption, right? So it was Steve Jobs' assumption that one day in the future all the future computers will be look like this only, that will have GUIs. So that was his assumption. What if his assumption was wrong? Then probably it was not as big company, or probably it may not have been done what he has done today. But his assumption was right, and now we see that all computers and even all the digital devices that we interact with having some kind of GUIs and so on. So assumptions and the claims. So often you have some assumptions and claims. Based on those assumptions, you come up with some new design. That's what Steve Jobs did. And you try to defend and support them, what they will provide. Similarly, another very good example of assumption and the claim is that nearly 20 years before, when Elon Musk has founded SpaceX, he said that he is able to help companies like NASA to probably take their satellites to the space with very minimalistic cost. And that is something he has assumed 20 years back with some and made the claim. And now we know that, it was true. He has worked really hard to achieve that, but that is the any visionary people assume and see the future like that, be it like Steve Jobs or be it like Elon Musk. So those that are difficult to articulate and can highlight what ideas are vague and unrealistic. Identify human activities and interactivities that are problematic. So that is something around this. So iteratively work on how the design ideas might be improved. Again, so based on the assumptions and the claims, you keep working towards that and so on. Similarly, another example is that other people think that after launching the satellites, the rocket will never come back. But through SpaceX, Elon Musk has thought otherwise. He said, why don't we just get it back? And we have seen that what he has accomplished around SpaceX. After launching the satellites, he was able to bring back rockets safely. So first in the sea, and just few months back, as you know, using his chopstick techniques, he is able to even land the rockets on the launching pad itself. So yeah, so assumption is basically one of the keys in building human computer interaction based systems. If the assumption is good, you are going to rock the world. If it's wrong, probably you are going to get destroyed. So in your assumption, you should not take something for granted. So as you can see here, taking something for granted when it needs further investigation. So for example, people will watch TV while driving. That is one of the assumption probably one of the manufacturer might had. But what will happen? That is going to lead to accident and many others. So in a way, that is the reason. It's not like you are going to install TV, at least for the driver. For passengers, you can do and so. So what is a claim? A claim stating something to be true when it is still open question. So for example, claim is providing visual feedback for button presses increase user confidence. So for example, when you click a button, so there should be some visual feedback, like you click the button. If you recall one of our earlier lectures, we have shown when the button has been clicked, you can see an impression, visual impression, it has been clicked. So button that changes the color when clicked make user feel assured that their action has been registered. It could be color changing, it could be probably kind of changing the size, small, or some kind of animation, GUIs and so. Another claim could be simplifying the navigation option, reduce cognitive load. So a website menu with fewer, more clearly defined categories help user to find information faster. So again, there is many such examples are there. Another claim is using consistent icon across interface improves learnability. So repeating familiar icons, for example, like save or delete, aids user in quickly learning the interface because often they are more familiar. That's how the often people use in different systems and so on. So let's do an activity. Can you make different assumptions and claim for this system called Rotimatic? Rotimatic is one of the Singapore company. It was startup then. And they had an assumption that if, for example, rotis is one of the main food for Indian people, especially North Indian people, if they go abroad, probably they miss their food. They assume that they are going to not change their food habits, but probably they are going to look for some system which can help them some rotis which are probably similar to home. And that's where basically they come up with this very interesting idea: make a machine itself. You simply add the flour to the system and some water, it will mud for you, and it simply basically give you a ready-made roti on the fly. And with this idea, basically they were able to raise kind of, you can say, the nearly $50 million in their fourth round of funding. And it's one of the good idea. Can you make more assumptions around this? Can you make something like Dosamatic, Idlimatic to make millions of dollars or billions of dollars and so on? So assumption definitely is a way to start with building something novel, interesting, and again, then try to find justifications. I mean, are you going in right direction or not? Similarly, there is another activity you can see. How will enabling robot waiters to speak to customer enhance their experience? What do you think? Will that enhance the user experience? So that is the one of the claim probably they have, one of the assumption they have, and accordingly they can make a claim that this will improve the revenue of the restaurant. So think about it. So the benefit is the robot could take orders, entertain customers by having a conversation with them. And robot can basically could make a recommendation for different customers such as restless child or fuzzy eaters and so on. But these are just assumption. But it may be the real problem being addressed or required to be handled at restaurant is it is difficult to recruit good wait staff who provide the level of customer service to which we have become accustomed to. So again, so think about the different assumption and the claim around the different real world problem around you, and start conceptualizing, start thinking about it, how you can solve it, and again apply all the design principles, design thinking that we have learned in earlier lectures. Let's walking through assumptions. Many unknown need to be considered in the initial stages of design. So for example, where do your ideas come from? Ideally, these ideas should come from by looking at the people or real world problems around you. What source of inspiration were used? Are there any similar systems are there? Is it feasible and so on? Is there any theory or research that can be used to inform them? Similarly, during the early ideation process, ask question, reconsider assumption, articulate concerns, and probably also get validated by the domain experts, get validated by the users, stakeholders. A framework for analyzing the problem space. Are there any problem with the existing product or user experience? Because you might consider building something only if there are some issues with the existing system, or probably you come up with some better features, or probably at least you are advancing something, or probably you are doing in some better way. So what do you think there are problems? Why do you think there are problems? Can you address this? So how do you think your proposed design ideas might overcome this? Because if you're claiming that the existing system may have some issues, user is not happy with the existing system, there are some problems, then you'll have to come up with the solutions. If you design for new users, how do you think your proposed design idea support, change, extend current way of doing things? So ideally, you should not try to change the behavior of the user, and you should do probably a similar way, probably with better user experience, more easy to use, efficient and effective way. So another assumption and claim you can think about, like what are the assumption and claim made by about watching a 3D TV. So probably when they made 3D TV, they assumed that everyone is going to probably take 3D TV at home to have a better experience. But was it really the case? It has failed. People not using it. Firstly, it was exaggerated, costly, very costly. Secondly, I mean, people start facing motion sickness. You may not able to probably going to have 3D glass to probably watch a 3D TV and so on. You may not be more comfortable. So there was no existing problem to overcome. So what was being proposed was a just new way of experiencing TV, what they have come up with. And their assumption was people would really enjoy the enhanced clarity and the color detail provided by the 3D. And based on that, they claim that people would not mind paying a lot for more new 3D enabled TV screen because of the new experience. So benefit of conceptualizing. So orientation, it enables design team to ask specific question about how the conceptual model will be understood by the target users. It's open-minded, so prevent design team from being narrowly focused early on. So its common grounds allows design team to establish a set of common agreed terms. So moving from problem space to the design space, so having a good understanding of the problem space can help inform the design space. So for example, what kind of interface, behavior, functionality you need to provide as part of your solution. Before deciding upon this, it is important to develop a conceptual model. And this is also more give you a more structured way of going ahead with what all ideas that you have that you want to achieve. So formally, a conceptual model is a high-level description of how a system is organized and operates. Another definition, you can see that designers to straighten out their thinking before they start laying out their widgets. So it provides a working strategy and framework of general concept and their interrelations. So conceptual model is basically a conceptual knowledge that is used to inform design and guide research. It includes paradigms, visions, theories, models, and framework. So let's briefly talk about them. So the paradigm is inspiration for a conceptual model, a general approach adopted by the community for carrying out the research. So they have shared assumption, concept, values, and practices. There are several established design practices, design thinking principles. People follow it. For example, desktop, ubiquitous computing in the wild and all. So examples of new paradigm in SCI: ubiquitous computing, pervasive computing, variable computing, Internet of Things. Many of these are part of your daily life that you see. For example, Internet of Things, all the devices that you have is somehow connected with your device and so on. So next is the vision, a driving force that frames research and development. So it invites people to imagine what life will be like in 10, 15 or 20 years time. That's what Steve Jobs did. Similarly, that's what Elon Musk did, and so on. Similarly, you can have a vision like smart city, smart health, human-centered AI. For human-centered AI, Professor Fei-Fei Li is one of the eminent figure you should look for. Provide concrete scenario for how society can use the next generation of imaginative technologies. Also raises ethical questions such as privacy and trust. So there are some tech visions as well. So how to enable people to access and interact with information in their everyday life. How to design user experiences where there is no obvious user control. How and in what form to provide contextually relevant information to the people. How to ensure that information passed around interconnected devices and object is secure, because there is a lot of data breach. You might have seen in different movies. I mean, they are able to probably hack a lot of personal information by connecting with your mobile remotely and many other things you might have seen. So there are theory, so explanation of a phenomenon. So for example, information processing that explain how the mind or some aspect of it is assumed to work. So there are many social science theories, cognitive theories, which probably can explain you that. Similarly, for different concept that you're using, so theory is kind of a kind of supporting argument for you to proceed in that direction. So it can help identifying factors relevant to the design evolution of interactive products such as cognitive, social, and affective. Similarly, can be used to predict what user will do with the different interfaces. So there are different models. It is a simplified. So the next is models, a simplification of an SCI phenomenon. So it enables the designers to predict and evaluate alternative designs. So it is abstracted from a theory coming from contributing discipline. For example, Don Norman, model of 7 stage of action, Mark, model of user experience, and so on. Similarly, for framework, a set of interrelated concept and or a specific question for what to look for, provide advice on how to design user experience. So it helping designer think about how to conceptualize learning, working, socializing, fun, and emotion. So it focus on how to design particular kind of interfaces to evoke certain responses or certain emotions. So it come in various forms such as steps, questions, concept, challenges, principle, tactics, and dimension. So a classical SCI framework is like by Donald Norman's framework of the relationship between the design of a conceptual model and a user's understanding about it. So it consists of 3 components: the designer's model, where the designer has how the system should work and look like. There is a system image, how the system actually work in practice, which is portrayed to the user through the interface, manuals, help facilities, and so on. Thirdly, the user's model, how the user understand how the system works. Ideally, it should be the same, how the system works and how the system think it should work or it is working. So they should be in alignment. If there is a gap, then probably your user is not going to probably complete the task it's supposed to do, and probably that will eventually end in frustration and reducing the user experience. So to summarize, so developing a conceptual model involves understanding the problem space, being clear about your assumptions and claim it should be supported some way, specifying how the proposed design will support users. A conceptual model is a high-level description of product in terms of what users can do with it and the concept they need to understand how to interact with it. Interaction type provides a way of thinking about how to support users' activities. So we discuss paradigm, vision, theories, models, and framework for that. And it provides way of framing design and research. So there are several conceptual model components. So the core components are metaphor and analogies. So understand what a product is for and how to use for an activity. For example, browsing, bookmarking. So for example, when you're reading a book, you bookmark something, some page. Can we do something similar in your book reading app? Or similarly, bookmark a web page, bookmark any information. Concept that people are exposed to through the product. So task domain object that create and manipulate the attributes and the option that can be performed on them. For example, when you save some file, when you delete some file, when you organize some file, move, and so on. So the relationship and the mappings between these concepts, for instance, whether one object contain another. So that is something we have to keep in mind. So first step in formulating a conceptual model, What will the user be doing when carrying out their task? How will the system support these? What kind of interface metaphor, if any, will be appropriate? What kind of interaction models and style to use? Always keep in mind when making design decision how the user will understand the underlying conceptual model. So for example, you can try to visualize this and try to answer if you want to search an information, for example, from the web. You can just take a simple example of Google search and try to fit here. What will the user be doing when carrying out their task? They're looking for information, they're putting some inputs. How will the system support this? Probably accepting the input and probably eventually giving the relevant files or information the person is looking for. What kind of interface metaphor you will be looking? So you use interface metaphor search, just like in real life you are search or find for something, and so on. So first step in formulating a conceptual model, there are many kinds and ways of classifying them. So the best conceptual model are often those that appear is obvious and simple. The operations they support are intuitive to use. For example, a conceptual model based on the core aspects of the customer experience when shopping mall underline most online shopping websites. So you can suppose if you have to build a kind of e-shopping website similar to, for example, Big Bazaar, Big Bus. For example, if you have to build some e-shopping website, so for example, similar to Big Basket or probably anything else, in that case, they also try to conceptualize the whole things like this. Similarly, they also use the metaphor like add to cart, just like in real life, you are carrying a shopping cart and put all the items there which you want to buy and go and buy. Similarly, we use similar functionality and metaphors when we are building so that people can relate with their real life. So for example, adding to the cart, proceed, pay, just like on the counter you pay and so on and get the things done. So there are interface metaphors like interface designed to be similar and physical entity but also has own properties. For example, desktop metaphor, web portals, and so on. So it can be based on the activity, object, or combination of both. So it exploits users' familiar knowledge, helping them to understand the unfamiliar thing. Similarly, in case of, as we're discussing the example of e-shopping experience, where basically you are trying to use the familiar knowledge. If you want to buy something, put into the cart. So that's why they add to cart. And when you pay at the counter, again, similar thing is complete the payment or do the payment. So conjures up the essence of unfamiliar activity, enabling user to leverage this to understand more aspect of unfamiliar functionality on system. So example of interface metaphor, conceptualizing what users are doing, for instance, surfing. A conceptual model instantiated at the interface, the desktop metaphor that we see on the Windows laptop or computers, visualizing an operation, something is happening. For instance, an icon of a shopping cart into which the user places items. So this is a card metaphor, as you can see that. So it is also quite popular because it has similar form factor. When you advertise something, it can easily be flicked through and sorted and themes. Its structure, content, and meaningful chunks similar to the how paragraphs are used to chunk a set of related sentences into distinct sections. Its material properties give the appearance of the surface of the paper. So benefit of the interface metaphors. So it makes learning new system easier so that you can relate with your familiar knowledge, relate with your real world life. So it helps user understand the underlying conceptual model. It can be very innovative and enable the realm of computers and their application to be made more accessible to a greater diversity of the users. but at the same time there is some problems as well. That is something we have to be careful when we build the system. So often you break convention and cultural rules. For example, recycle bin has been placed on the desktop of your laptop or computer. You never do in your real life. You don't put your dustbin on top of your table, right? So can constrain designer in the way that they conceptualize a problem space. So often conflict with the design principles. It forces users to understand only the system in terms of metaphor, and eventually it is much more than that. The designers can inadvertently use bad existing design and transfer the bad parts over. Limits designers' imagination in coming up with a new conceptual model, because they think, I mean, what if you don't understand? What if you don't like it? So this is an activity for you to describe the components of the conceptual model underlying most online shopping website. For example, shopping cart, proceeding to checkout, one click, gift wrapping, cash register, all those things you might have seen. So let's next talk about cognitive aspect of the interfaces. So there are some key aspects like perception, attention, memory, mental model, decision making, and problem solving. So let's go each of them one by one. So what is perception? So how user perceive visual and auditory element of the interface. So for example, using contrasting colors to make buttons visible, and in fact you can see that of perception ensure that a user can easily identify interactive elements. Attention, so it directing user focus to important areas of the interface. Example is notification pop-ups or highlighted error message that you give. For example, whenever you're filling some online form, there are some fields which are mandatory. Form is such a big, you can't fill all the information. You sometimes you see, okay, just leave it, or probably you're not filled the right way. For example, sometimes on some website you'll have to create some password based on some constraint. It should have this many alphanumeric character, this special symbol, and blah 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 and so on. So basically, if you're doing the mistake, rather than just telling it's not right, ideally it's good to tell what is not right so that you can fix that and proceed. Otherwise it's very frustrating and lead to a very bad user experience. So it prevents the user from missing critical information. So memory, reducing cognitive load by minimizing reliance on the memory. So for example, autofill feature in online forms to avoid re-include. So often, for example, when you are filling a lot of forms, it try to pick the address. So what if I already filled address in a couple of forms, just pick from there. And that is something you might have seen many of your places. So impact enhance user convenience and reduces errors. So there are some cognitive principle interface design, that is Hicks law. So the time to make a decision increase with the number of choices. So for example, grouping menus into categories for easier navigation. So if you keep that in mind, I think you can help user in reducing the time to complete some task. Similarly, Fitts law, so that is about the time to target an object depends on its size and distance. So application is like large clickable buttons close to the user focus area, so that they can, rather than moving a lot, they can simply click and they don't have to move a lot. So the next is Gestalt principle. So that is about user perceive elements as part of whole, so grouping related icons and control together in the toolbars, so that it's easier for you to basically perceive the whole as a group and perform the subtask by going inside that. So Miller's law, the average person can hold 7 plus minus 2 items in their working memory, just like RAM. So the applications, so limiting the number of options displayed at once, because as you can see here, a person can remember just 7 plus minus 2, that is 5 to 9 things at a time. If you show so many options, the person is not able to probably focus, not able to probably get it done, or maybe get confused. So some real world example that you can see, the Google search, minimalistic design with a clear focus on the search bar, very minimal, and then probably you can offer some constraint to sell. It leverages attention and mental model for quick search input. Similarly, Spotify app that recommendations tailored to user preference reduces decision making load, employs memory and problem solving principles. Similarly, for ATM interfaces, simple workflow on the screen instruction, withdraw, check balance, and all with the mental model and the ensure usability. So some characteristics of good interface, it should be user centric. So that is designed with the user need in mind. For example, accessibility feature in the Apple product like voiceover is one of the key user centric things you have. Consistency. So predictable behavior across the system. For example, similar toolbar design across Microsoft Office suite that you use in daily life. Feedback, clear response to user action so that the user can understand whatever the action the person has taken, it has been completed or at least it has progressing. So for example, email sent, message sent, confirmation on the WhatsApp or Google Gmail and so on. Error handling, it helps the user to recover from the mistake. For example, undo button in Google Doc, because you may tend to do mistakes, so how to undo. So earlier email doesn't have the undo feature, but after realizing and it's more understanding the needs of the user, because you may just hit the send button by mistake. So they basically give you error handling. They give you few seconds to undo it. Similarly, there is another example whenever often you send an email and say, please find attached file, and often you miss or forget to attach the file. So in that case, rather than sending them an email, so now they ask you, okay, so have you missed the attaching the document because you mentioned attach? Earlier it was not the case, but now it is there. Again, this is how it evolves. This is how it iteratively improves the system. Aesthetic appeal, so that is balances functionality with visual design. For example, Airbnb, our favorite examples, minimalistic interface and so on. So if a user can't use it, it doesn't work. So it has to be quite good interface through which they can do it and get it. So there are more emerging trends in interfaces. So now we have AI powered interfaces, multimodal interactions. So now we'll be looking at some of them in the upcoming lectures when we study smart UI. So for example, Tesla car has smart UI. Similarly, AI powered interface that you can see, adaptive system that learn user preferences, and Netflix recommending content based on the viewing history and so on. Augmented reality and mixed reality, so that is again overlaying elements on real world setting. That is something Microsoft HoloLens, another example we have studied. Brain computer interface, so where basically directly communicate between the brain and the device without any physical interaction. So Neuralink exploring brain control system, which is the example. So some challenges in interface design. So accessibility, one of the most important thing you need to handle. So designing for user with diverse abilities, for example, caption for hearing impaired users on the YouTube. Similarly, cross-cultural usabilities. So interfaces must work across languages and culture. So Google Translate, multi-language UI is quite good. Privacy and ethics. So again, balancing the functionality with the user data protection. So for example, Facebook's privacy setting for controlling shared information, whom you want to see your post, and so on. Similarly, on the WhatsApp, you might have seen that when you were conversing, they mentioned it has encoded with encrypted with these many bits and so on. So hardware limitations. So designing for devices with varying specs. So for example, lightweight UI for budget smartphone and so. Ubiquitous interface, so seamlessly integration into the daily life. Example, smart home ecosystem like Amazon Echo, probably Smart Light and all those things that you see. Emotion aware interfaces, so system that adapt to the user emotions. So wearable tracking emotion states like Fitbit, there are Empatica, all these watches are basically help you in a way taking care of your health being as well. So interface features, as a case study, you can see that Oculus Rift is one of the interface. So it has immersive 3D environment for gaming and education. It has hand controller and the motion tracking for input as well. So SCI contribution, so it enhances accessibility for by simulating environments, applications in therapy like phobia treatment and all those things that you do, and many other things you can do. So lesson learned: importance of reducing motion sickness and prioritizing user comfort in immersive design. So activity for you. So given prompt, sketch an interface for a new smartphone device, identify features that align with SCI principle, discuss how the interface supports usability, feedback, and accessibility, and the objective is reinforce understanding of interface design through hands-on activity. So with this, we come to the end of our this week. So where in summary, interfaces is a point of interaction between the user and the system. A well-designed interface facilitates ease of use and intuitive interactions. So key aspect is usability, feedback, consistency, and visual clarity. Conceptual model is more about mental representation that users form about a system, how system works. So it help user predicted and understand the user system's behavior. So design goal is align the interface with users existing mental model for better usability. And finally, the cognitive aspect, how user process information and make sense of interfaces. And importance you can see from this is designing for cognitive efficiency reduces user frustration and error. And while building this, the key consideration are cognitive load, memory limitation, attention, and perception. So some additional material you can see we'll be covering as part of this week. So we'll be having cognitive aspect tutorial by our brilliant TA Ritvik Bamba. We'll be having a tool demo on Behance by Arushi. Similarly, we will be also having a tool demo using Adobe Express on design mockup for mobile app using Adobe Express. So these are further resources if you want to get more details about the topics. I highly recommend you to probably go through them. With this, I stop here. Thank you so much.